Okay, then let me share my screen. So, we will be explaining valid Sudoku. Uh, I will be explaining these three questions. In fact, these two questions are almost similar, so I'll be explaining them in one go. And this problem is very small, so I'll be briefing it like through a dry run. And Michael will be explaining this problem, but he'll be joining at 7:30. So by that time, we'll cover the rest of the problems. So Avi, would you like to go first, or shall I explain my problems first? Avi? Oh, sorry, I realized I didn't unmute my mic. Okay, so Avi will be explaining valid Sudoku, and I'll be explaining 11 and 12 question. These two questions are same, so I'll be explaining them in one go. And this fifth problem is very small, so I'll be explaining the dry run of this problem. And Michael will be explaining the eighth problem, which is longest consecutive sequence, and he'll be joining at 7:30. So by that time, we'll cover the rest of the problems. Avi, would you like to go first, or shall I explain my problem first?
I will go first.
Okay, fine.
Is my screen visible? So this is the valid Sudoku problem. In this problem, generally it is the brute force solution. I searched it everywhere and I tried to code it. The problem is generally we have to do a brute force. The in this first we have to as the question says we have to first go from the first position to the last one for the every rows, and for every columns you have to check if the numbers are same or if the any number is same from 1 to 9 or not, and we have to search for a 3 cross 3 matrix, like here 5 3 and this string 6 blank 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 9 and 8. So we have to search if in this 3 cross 3 the numbers are same in the range of 1 to 9. So here I have run a yeah in this part. First I'm writing a for loop. I'm first I'm checking if the board length is greater than 9 or it is a null. So we will return false as this is not a Sudoku. Then we are writing a for loop. In this we are creating a new array for checking from the if the numbers are present. We are checking for the first row. We are checking if the numbers from 1 to 9 are present in the array. Is a present previously present in the row or not? So this is generally a brute force solution. It is n cube solution. So first from here to here, we are checking like 5, 3. We are putting 5 into the array. Then we are creating a Boolean array like from 1 to 9, 0 to 9, and we are checking if the 5 is there or not. If the 5 is not there, then we are putting in the 5 place in the fourth index true, and then we are putting in the third index in the second index true, then we are moving forward. If we are checking in the sixth index true, and then if the element is not present, then we are moving into the second row. Similarly, we are checking through all we are going through all the rows of the matrix, and similarly for the columns. Then we are going for the 3 cross 3 matrix. There are nine blocks. So first we checked it in a ways like dividing the problem into three rows into three parts. Uh, this is the first row. This is the first row matrix. This is second row matrix, and this is the third row matrix. And we are checking all the elements. If similarly we are checking a boolean, creating a boolean array for the 3 cross 3 matrix, and we are checking if the number is available or not. So everybody is clear, I think so.
So basically, that's the brute force approach in which you check whether it's present in the other subsection or row or column or not. Based on that, you fill it.
Y- yes, I searched it everywhere, but I found a brute force only. So this question generally contains a brute force solution only.
Okay, I saw some solution using strings. I provided the editorial link in the roadmap itself. So I think that's a better solution, maybe. I haven't looked into it. I haven't solved this problem, but you can check that one.
Is it possible to solve the problem using backtracking? Because this problem looks somewhat like the chessboard problem in which you use backtracking.
Mm,
Okay, I
um,
will look into it. But I found
Backtracking,
this
I'm not
solution
sure
only, so I shared it.
because in backtracking,
Yeah, I
it would
also saw.
be like the time complexity would increase, would be exponential because you're filling one element and then checking out.
We can
Uh,
do it also using map also.
Yeah, time complexity would be exponential, but I was like trying to look for a different way to approach this problem. Because
uh,
um, see, I was also able to solve it using brute force, but what I thought was there could be some better way, but yeah, I was not able to figure it out. So I was thinking into a backtracking kind of approach because this one is similar to the chessboard problem. Yeah, that's it.
yeah, okay. The backtracking would definitely work because you are checking for every possible value, and if you found some value which is satisfying all the conditions, then that's the answer for it. But if the question is around what is the question? Valid Sudoku, right? It's over here. So the eighth question. If you scroll down to the solution section, I have provided a link to the this question editorial, and this guy used some strings to ease out the problem. Okay, so you can look into that. I haven't looked to this solution. You can do it yourself. Okay,
Yep.
so let's. Any other thing about this question? Any other idea you have?
We can use map also. So for the all the we can store it in a map for we use a map for it. So we can assign the numbers are placed in a row in a column. Then we can do it. So it uses a single map only. So this can reduce the space complexity.
Hmm. Okay, yeah, maybe storing into map. Yeah, so that kind of method is explained in the video itself, so you can look into that. Mm. All right. Let's go to the next problem. I guess. All right. So the next problem is, shall I explain the grid unique path first or the other two problem?
I think great unique path first.
Okay, it's a small problem, but it won't take much time. So let's go with that. Yeah. So grid unique path is this problem in which we have to what we need to do is how many possible unique paths are there such that the robot can start from the top left corner and reach the bottom right corner. Okay, and if you go to the drawing section, there are two approaches. There is one a mathematical approach and there's a DP approach to this problem. The ma- so the mathematical approach says that the logic or intuition behind is like to start from the top left position and to reach the bottom right position. What you need to do is you need to move two steps down and uh, one, two, three, four, five steps to the right. All right, and you can do this in any order. Like you move one step down at the first step, then move two steps right, then move one step down, then move three steps right. All right, so it does the same thing. Like if we write it down, so this is down. This is okay. Let's make it a little clear. Okay, the steps down, right, right, down, right, and finally right. Okay, so the movement is restricted towards only moving downwards and only moving rightwards. Okay, so this position, this one is down, this step is down, this step is right, this step is right, this step is down, this step is right, this step is right. All right, so if I interchange any of the value, suppose I move down first and right for right second after this, so the change, all the change would be moving down right here because this is the new step, and this is the right, so we're going right. So instead of, so it creates a little different path by swapping the R and D. So since to reach towards the target, we have to the steps are predefined. We need to take one, two, three, and four rights, one, two, and three, and four rights, and two downs. So the problem basically boils down to combinations of this particular string. Okay, it can be anything. It can be any other combination. So since we have two number of D's and we have four number of R, so the combination formula was number of R, that is, suppose let's say it is M and let's say this is N. So let's move it a little down. All right. So the combination formula turns out to be N plus M um, C of N or M probably. Yeah, NCM. This is the combination formula for all the possible rearrangements. So this can be calculated by NM n plus m factorial divided by n factorial into m factorial. So that's the formula. If you look at the code for it, it's explained in one of the solution section, discussion section. It's just calculating the formula. Just a minute. Just a minute. Mm, where is the? Okay, that work. All right. So this particular formula, what it states is we had m plus n divided by m factorial into n factorial. So what we did is we expanded this m plus n factorial to 1, 1 into 2 into 3, and we went till mm, n minus 1 into n, and then we went on to n plus 1 till n plus m. That's the whole numerator, and below it it's 1 to m, and it's 1 to n. All right, so if you can see, we actually can, this portion and this portion are equal, so this gets cancelled, and the leftover portion is um, is basically n plus 1 to m divided by m factorial. Okay, so it's just like m plus 1 towards m plus n divided by n factorial. Okay, I took a little different variable, but let's just change it right here. This is m, this is m, this is m, and this is n. Just, this is n, this is m, and this particular variable is n. So yeah, so the formula boils down to this, that is m plus 1 into till m plus n divided by n factorial. So the whole logic, or the, to prevent the overflow, we do is we first in the for loop, we first have a 1, then we multiply it by m plus 1 and divide it by 1. Okay, then in the next iteration we multiply it by m plus 2, and then divided by 2, and then in the next iteration we multiplied by m plus 3 and multiplied by 3. So you're getting the idea, right? That we are, whatever we are adding with, we are dividing by that number. So that's how it won't overflow, is because we are multiplying at the first time, multiplying and then dividing at that point of time. So the whole solution looks like this, that we are moving from m plus 1 towards m plus n. Okay, like right here, the formula, as per the formula, we are moving from m plus 1 towards m plus n. right? So because of that, in the for loop, we move from m plus 1 to m plus n, and at each position, at each point of time, we multiply by m plus 1 and divide by that number 1 or 2 or whatever that is. And to do that, we use the j pointer. So basically using the combination formula over here, and that way we can calculate the whole number of unique path. So the complexity of this problem would be basically O of m or n basically. And why is it so? Because the for loop is running n times, right? M plus 1, m plus 2, m plus 3, and up to m plus n. So this is the whole number of operations it's gonna take. So that's why this is taking O of n time. But if we go for the DP approach, now since this is a mathematical solution, it doesn't require any other extra space. But if you go for the DP approach, we will be requiring uh, a space of n cross n, m cross m. What should I do? Let's erase this. I'll briefly go through the. I'm audible, right? Yeah, yeah, okay. Mm. By the way, this is awapp.com, so you can use that if you want to at any point of time. Okay, let it be like that. Or let me erase that. Mhm. Cool. Um, so for the DP approach of this problem would be to reach this particular box, we can only move down, right? So the number of ways we can reach over here is 1. And similarly, to reach over this box, we can actually move from the above position only. So the number of ways we can reach to this box is 1. Same goes for this box. To reach over here, we only can come from here. That is, okay. The DP approach says we need to move towards every particular box and calculate the number of unique paths to that and then add it up. So to reach this box, we only have one particular mm, way. Then over here only way, because this is the only possible path, this is the only possible path, and hence we first declare 1 at each position. Then we move on to the other portion and we iterate in this particular subarray, and to reach this and to reach this particular box, we have two possible options, that is one from here, one from here, and one from here. So that's why this box will contain 2. And how do we obtain that? We obtain by adding the above position and the leftmost position's value. Okay, so 1 plus 1 becomes 2. Similarly, for the next box, this one, also we have, sorry, just a second, just let me remove this. Okay, fine. So for this box, we have actually 3 possible ways. How? Let me show you. One is this one is this one, and one is this one. And how do we get by the observing the adjacent values? We add this one and this two. That is the value at the top and value behind this particular box, the bubble box. Hence you got 3. And the same concept applies to every box. That is, this one is 1 plus 3, that is 4. This is 1 plus 4, that is 5. Okay, 5. This one is 1 plus 2, that is 3. 3 plus 3, this becomes 6. 4 plus 6, that becomes 10. Now finally we are at the target, and for the target value we have, this is the target value. To reach over here, all we need to do is we need to add this 5 and this 10, and we got the answer as 15. This is the answer. Okay, we can check it also. If we never mind, just the answer is 15 because that's the DP approach, and we need to check the only two elements, that is above it and the left of it. So it's defined right here. We are adding the position that is above us and the adding position which is below us. And a follow-up question would be that if the movement diagonal is someone okay, if the diagonal movement is also allowed, what would be the number of steps? So the problem won't change much, is because we would be taking the diagonal value addition as a additional factor, right? Like what I'm trying to say is, suppose this is the target and these are the values predefined. So up till now what we considered was this 10 and this 5, because from these blocks only the robot could have reached the target T. And if you introduce a diagonal factor also, so this is also a position which we need to consider. So till then, so for that we need to add 10 plus 5 plus 4 as well. All right, so in the code it turns out to be, we will be adding another variable, another index as well, element as well. So since this problem only has two operations allowed, that is down and move right, so we did that, and finally we returned the target value. That's how the unique path problem is solved. Okay, any questions regarding this problem? Thanks, unique grid path. This problem, no.
No, nothing.
Okay, fine. If anything, it's clear. Hmm. So can we use recursion? Yeah, actually, in one of the, am I audible, right? Yeah, yeah. So in one of the solution, they have provided a recursive solution. Okay, and it's very easy to code it out, because the idea is just to use the function again and again. But the number of overlappings is really huge. So it's like to explain why this overlapping is huge, I'll try to explain in a short way with a small box, maybe having few elements. Okay, I am having 2 rows only. Or maybe let's make. Sorry for the bad drawing, but it's just immediately I have to do it right now. Okay, so the thing is, if we are finding out, because with the recursive function, what we're doing is we are first calling the function with passing the parameter m comma n, or maybe specifically m minus, or let it be m comma n. This is the m and n indices. So with that, we are calling this function. All right. So this function calls two functions, that is m minus 1 comma um, m minus 1 comma n. All right, which is this, calculate this particular unique path to to this element. And another one is n m comma n minus 1, so which is basically calculate this particular, for this particular element or index. So again, this particular, since this is itself of the function is running for this, so this box, let me change the color. So this box will be calling, this big box will also call for function of this box at some point of time. So will this box call this particular function for function for this box. That's why it is getting repeated, right? like like um how shall I explain this? uh, See, this particular function, right, is for this box. And if you see the overlapping or whatever sub functions it's calling, it will obviously call this functions because function for this box, because the values are getting decremented at uh, each call. That's why it will call this particular box. And same goes for this, same goes for the other function. If we find out the sub functions which it will call, it will also call the same value. So the problem over here with this approach is that at every point of, with every box, the the sub the sub calling o- will be calling the same smaller box a large number of times. That's why it is overlapping, and hence this won't be an effective solution. We need to move on to the DP approach or the mathematical approach. Okay, is it clear now?
Kunal, like in a Fibonacci series, we calculate the this question, the method you told, the second method, like in recursion with use Fibonacci series, we calculate fn minus 1 and fn minus 2. In the similar way, in this question, if we calculate both the boxes, then we are using the box between box before it and above it, so it uses it multiple times.
Um, yeah, I'm not sure what you're trying to say. The whole, like, just the whole
Uh,
idea, if you make the recursion tree over here, you will find out that since each box will be calling sub functions, so every box will call, suppose the initial box is this one, which is, it is below this box is called in the bottom row of the recursion tree, right? So every other box which is present in the topmost position will be calling this box. That's why it's overlapping, and hence it increases the time complexity.
okay.
Right, right.
What he's trying to say is that when you call Fibonacci function in recursion, so there when you call Fibonacci 2, it will call Fibonacci 0 and Fibonacci 1, and when you call Fibonacci 3, it will call Fibonacci 2 and 1. So one would overlap in both the subtrees. And similarly in this question, Kunal, can you just open the OR board once more? Yeah. So here the red mark box, the box which is marked red in the bottommost row,
Yeah, yeah.
it would use the cell towards the left of it and just above it, because you can reach that cell from the one above it and from the left of it.
True.
And similarly, the box which is marked yellow right there, uh,
Yeah, yeah,
above
this
the,
one.
yeah. So you can reach it from the left one of that one and above it. So the box which is like, there's a box which is common to both.
Yeah, this
So
box. Yeah, I get it.
this box, yeah. So this is the overlapping part, and with DP we store it.
Yeah, so this
Yeah,
one is the overlapping portion, which is common for both the red box and the
yeah,
yellow box itself. That's why. Yeah, I could have. That's much more simple to understand.
yeah,
Okay. So I think it's clear. So Anna, let's move on to the next question if and no one has any doubt. Okay, so now we sorry. Now we have two questions, that is 11, 12, or the eighth problem. Okay, so till now we are done with, let me just erase everything. So we are done with valid Sudoku, grid path, and we are left out with three problems. Michael, would you like to explain the eighth problem first, or shall I explain the two problems?
No, it's fine. I'll go.
Okay, okay, sure.
So, so uh, how do I present my screen though? Yes. Share. Okay, are you guys able to see my screen? Okay. So the problem that I'll be explaining is the longest consecutive sequence. Okay, so in this problem, what we have to do is, let's say we are given a sequence 1, 3, 5, 6, and 7. So for every number, we have to check the longest sequence that can be formed. Now, and the sequence should be consecutive. For example, if I take 1, then I need to have 2 in the array. If I don't have 2, then I cannot consider it as a longest sequence because the sequence size then will be restricted to only 1. So if we just take 1, then the sequence size, the maximum sequence size, will keep a note of it. Let's say maximum sequence size, and will iterate over the first element of the array, which will be 1 over here, and we'll take 1, and at the moment our maximum sequence size will be 1. Now we'll search for 2. Is 2 available in the array? 2 is not available. So what we'll do is we'll skip that part and we'll go for the next element, because since we cannot form a longest consecutive sequence over here, so we'll go for 3, and then from 3 we'll search for the next elements of 3. So for 3 we'll search if there's 4 available. Since there's no 4 not available and the sequence size over here is also 1, so it resembles with the maximum sequence size that we have, and therefore it will remain 1. Now when we come to 5, now for 5 we'll search for the next elements of 5, that is 5, and then afterwards we have 6, and then we have 7. Is there some message? Like you're asking for my approach? N square? Yes, because this is the brute force approach that we are discussing at the moment. We'll optimize it later. Not an, okay, so for 5, 6, and 7, the length that we have over here is 3. So what we'll do is initially Now in this code, what I have done is, now this is the base case that I'll be checking. If the array is 0, that means array does not have any elements, and the longest consecutive sequence that we'll be having is 0. This line of code over here. And then what we'll do is we'll initially set our longest sequence to 0, and then we'll iterate over each and every value of the nums array. So we go from I to 0 till nums.size, and then we increment every value. And what this contains function will do over here is, I'll explain it. Okay, so let's take this example: 100, 4, 200, 1, 3, and 2. Okay, so the first number that we'll be taking over here is 100. Now, when we take 100, we'll have to search that if we can make any number less than 100 as a possible sequence of it or not. So for 100, we'll search if 99 is in the array. Because what we want to do over here is we need to find the start of the sequence. Now, if let's say there was 99 in this array, somewhere over here, let's say there's 99. So the sequence would be 99 and 100. So what we'll search for here is we'll search the smallest possible sequence from where we will start our array. So if we have 98, that will be the one which will be our starting point. So I'll say from 100 we'll search if 99 is in the array. If 99 is in the array, then we'll skip 100, because 100 will initially be like 100 will be encountered later when we start a sequence from 98. So we'll skip 100 for now, and we go for the next value, which is 4. Now for 4, what we'll check is if 4 minus 1, which is 3, is there in the array or not. Now since we have 3 in the array, we'll skip 4 as well. So the next is 200. Now for 200, what we'll check is, for 200, we'll check if there's 200 minus 1, that is equals to 199. If 199 is in the array or not. Now since 199 is not in the array, we know that we can start a sequence from 200. So the sequence length that we have at the moment is 1, because that will be the minimum sequence length we'll be having. Okay. And then for 200, what we got is 1. Now we'll start another sequence that will be from 1. Now for 1, what we'll search is if 1 minus 1, which is equals to 0. Is 0 in the array or not? Since it is not there, we know that our new sequence, and for that new sequence, 1 is the smallest value. So if I just go on incrementing uh, 1 from 1, that is, let's say initially I take 1, then 1 plus 1 is equals to 2, and then for the next sequence I'll take 2 plus 1 is equals to 3, as long as I find values in the array. So for 1, what I'll do is I'll check if 0 is in the array or not. Now after this check, I know that 1 is the smallest value, and I can start a sequence from there. So I'll search for 2. Now since 2 is there in the array, I'll search for 3. 3 is there in the array, I'll search for 4. And after 4, I'll search for 5. And since 5 is not there in the array, it breaks. So the sequence that we form over here is 1, 2, 3, and 4. So what we are doing over here is, see, I'll write the contains function over here. A boolean contains, that will take a vector numbers, and this will take the number that we have to find in the array. Let's take it as the target, and we'll run a loop for our entire array. For int I goes from 0 to I goes till nums.size, and if the nums of I is equals to target, then we need to return true, because we found our value in the array. If none of the elements in the array satisfies our target value, then we need to return false. Okay, so this is the contains function that we wrote over here. Now, from what I told, for every value that we iterate, that is from I equals 0 to nums of size, we check if the nums of I minus 1 is there in the array or not. That is for 100, we check if 99 is there in the array or not. If 99 would have been there, we would have just skipped this part because we'll start a sequence from 99. That is, we're trying to start a sequence from the smallest value we have in the sequence. That is, for the sequence, let's say 98, 99 and 100. We'll try to start and build up a sequence from 98. So if we search for 99, we know that if 99 is not the smallest, then 98 would definitely be there in the array. So if we find 98, we just skip that particular section, and because we know that 98 is there, we'll start a new sequence from 98, and at the end we'll encounter 98, 99 and 100, all of them. So if not contains, and then whenever we find a particular value from where we have to start that sequence, the sequence length would be minimum 1. Now the number to consider is, now let's say I was at 98 and I check for 97. So the 98 is initially considered, so I'll check for 99. So therefore the number to be considered will be nums of I plus 1. And then all I have to do is I have to check whether 99 is there in the array or not. If 99 is there in the array, then all I have to do is I have to increment my num to be considered plus plus. That is, if I search for 99 and I find 99 in the array, then the next number that I'll be checking for is 100. So therefore num to be considered plus plus. And whenever a particular value is not found, let's say for 100, when I do plus plus, I'll be landing up at 101. Now 101 cannot be found over here. So the length of the sequence will be given by the smallest value minus the value which we ended at. That is 101 minus 98. 98 can be found from nums of I, and the num to be considered is 101. So 101 minus 98 will give me 3, which will be the length of the sequence. So the last thing that remains over here is, once this thing is over, now the longest sequence is equal to the maximum of the longest sequence minus maximum of longest sequence comma the num to be considered minus the num supply, and at the end return the maximum, no, return the longest sequence.
I guess for the duplicate value, we'll use a hash set to remove the duplicate values.
For the duplicate values, you mean? Mm, no, duplicates won't be considered over here. Since this is a brute force solution, though, for the duplicates, what we'll do is we'll even be counting if there are duplicates in the array. So we need to somehow optimize this solution. But first, let's discuss the time complexity of the solution. Now, the first loop over here runs for order n time because it runs from 0 to the size of the array. So this will run for order n time. Now within that, what I check is, for, let's say, for every value, what we're doing is we are trying to find the longest sequence. Now that can range from the start of the array to the end of the array. So this while loop entirely will run for order n time in the worst case, and then the contains loop inside here, which will search for that element in the array. This will run for again order n time. So the overall time complexity over here will be order n cube. Like, any doubts still here? Okay. So now the first thing that we can see over here is we are finding the element in, if we are finding that whether the element is in the array or not. Now that thing can be optimized using a hash set, because what we're doing is we are taking an order n time to just search the element in the array, which can be reduced to order one time using a hash set. So what we'll do is we'll use a hash set and put all the values. We'll create an unordered set of integers, let's call it s, and we'll insert all the values in the nums array into the order set so that our search can be optimized. Yeah, I got, I like, I guess I pressed the insert button. Okay, is less than num set size I plus plus, and then we just need to insert all the values of the array into the hash set. Now we can get rid of our contains function, and here when we are checking for nums of I minus 1, we can only check whether it's not there in the hash set or not. So what we need to do is we need to find the nums of I minus 1, because for every value what we are checking, its previous value was present in the hash set or not, so that we can find the smallest number from where we can start our sequence. So if we do not find this value, then we have to, so if it's equals to the set dot end, okay, and then over here we can just replace the contains with this. We can get rid of this number to be considered, and okay, so we reduced our search to order 1, but we are having another problem over here. Can anyone tell me the time complexity of this solution? And can you justify it? Like, why is it often?
I think n of s square is over.
Yeah, it looks like it's bigger of n square though.
Okay.
Yeah.
Because what we are doing is we are iterating over every element in the array, and then we are searching for all the possible values that are there. But okay, no.
Yeah, so basically what you did is remove the search function, right? And instead of that, you use the
Yes,
hash
I removed
function.
the search function.
So
Yes.
searching was taking was making the whole complexity n square. So removing that would make it O of n, right?
Yes, that it works in order n time, because what we are doing is we are only iterating for the smallest number in the sequence. And whenever we find a value which is in the mid of the sequence, let's say we come over at 3, and for 3 we are checking if 2 is in the array, and if 2 is there, then we are skipping that iteration altogether, and we are starting the sequence iteration only when we land at 1. So the time complexity over here looks to be order of n.
Okay, nice. I would like to add a visual representation to this approach if you are done with your explanation.
Yeah, sure.
Okay, let's create a new board. Start drawing. Okay, so let's take the example what he took was maybe 100, and let's introduce another 100, or maybe 4, then 100, then what do we have? We have 1,
It was 104, 200, 132 though.
200. Okay, okay, or 200, 1,
100, 4,
2,
200, 132.
3, 2. Right. This is it.
Yes.
Okay, in this, his approach was basically to check for the consecutive sequence, right? So as we can see, we do have a sequence, like if we start from 1, then go to 2, then go to 3, then we finally go to 4. Okay, so this is the longest consecutive sequence which we can have. But if we let's suppose introduce like what she said for duplicate values. So right here, if we have a duplicate value, we'll simply use a hash set to remove all the duplicate value, and obviously that won't change the um, let's make it 3 rather. Right, this inserting a duplicate value won't change if I sort the array, will time complexity be reduced? Will time complexity reduce? Sorting won't change, won't actually reduce the time complexity. It would increase it because it's the fastest sorting complex algorithm takes n log n time. Anyway, so we won't be using the sorting approach. We'll be simply using the hash set approach which he mentioned. So if we have a duplicate value, the sequence still remains same because it's 1, 2, and it goes to 3, and then it's finally going to 4. The duplicate value is just staying there. It doesn't changes the sequence count. So a simple approach would be using a hash set and removing all the duplicates value. Hence, we'll be coming out with only the unique values like this. Now the now if we start from 1, we can see this is the unique. This is a one sequence. But if we start from, suppose, let's say 2, we have another sequence possible of length 3. So this is of length 3 and this is of length 4. Just a minute. Yeah. So there are two sequences which are overlapping actually. For the first sequence, you have 1, 2, 3, and 4, which is starting from 1. And for the other sequence, that is 2, 3, and 4, this is starting from 2, right? The below one which I mentioned over here. So this is of length 3 and this is of length 4. And why is it happening? Why, if we count possible sequence from every point of every element, we obtain two sequence. This is because we are also considering the sequence starting from 1 and also considering the sequence starting from 2. So that's the issue right here, because we are also considering the sequence which start from the second element. So like Michael mentioned, we need to consider the sequence which start from the very first, very minimum element. That's why we that's why whenever, suppose we come across 2, right, we come across 2 and we see, okay, there exists another larger number which can form a sequence. We must also check whether there exists a 1 or not. If there exists a 1, that means a sequence from 1 will already exist, and the sequence 2, 3, 4 will be counted in the sequence 1, 2, 3, 4. Right, so you're getting my point, right? that
Yes.
we need to check the previous value. So because of that, because that particular value will be forming a larger sequence as compared to the value 2. That's why we need to check whether the previous value exists or not, and if it does exist, we simply ignore this particular sequence, that is 2 3 4. We are ignoring because the value 1 also exists in the hash map. And how do we check? We just simply check in the hash map using the find function, I guess, whatever function we have that runs in o of one time. So finding is not an issue. Instead of traversing the whole array, we are using a find function in the hash set that uses O of one time complexity. That's why we are coming with O of n complexity, because we are uh, for one, we are going through the entire sequence. We are checking whether 2 exists, 3 exists, or 4 exists. That we counted as one sequence. But once we come to 2, we see that 1 already exists, hence we are going to ignore it. That's why 2 is only counted at one time. So every element is is observed one time. That's why the complexity remains O of n. Yes, I have to leave. Okay, yeah, we can go. Yes, no issue. I know the code forces around is clashing, so you can go. I'll be posting this whole video on YouTube. Okay, so you guys can see the explanation there as well. Yes, if anyone wants to leave. Okay, bye, Anurag. Fine. So I guess that's the explanation to why he used such approach and why we are ignoring the previous value. Let's move on to the next question. That is this question. Subarrays with. It's an interesting question. Now we are only left with two questions. That is, this is done. 11 and 12. So 12 won't take much time. After we are done with the 11 question, we can easily switch to 12, and it's similar question. Okay. So we'll be understanding what 11 question mean. We need to do in that. So the question is, we need to calculate the number of subarrays that are having the products less than 10. Now I know this question is not of hashing; it's of two-pointer or sliding window technique. But this technique is used in the other question, and that's why I have included this question in this topic only. Okay, so um, I'll try to make it as short as possible. So let's first begin with this over here. Let's first analyze what we can do. So the brute force approach for this question is to check every possible subarray, right? And check whether it satisfies the k condition, whether it's less than or not. But that would obviously take off a O of n square, right? Because we are checking for the first element, we are generating all the subarrays. Then we are then we are going to the second array element, and we are generating all the subarrays. That's why it's taking O of n square. So what we need to do is we need to somehow improve that time complexity, and to do that we can observe few things. So if we like what's happening is in the brute force approach, we are it's like overlapping is happening. We are checking some elements again and again. That's why we need to switch to some other idea. So since we want a subarray, this is a clear indication that we have to use a sliding window technique or two pointers technique. And subarray by definition is a contiguous array. Right? Contiguous means I cannot break the array. right? Like I have 2, 3, and I have 7, 8. So this particular array is not a sub array. It's because it's breaking the 4. 4 is not present in the entire array. We have to consider the entire sub array. Okay, there's no breaks allowed inside this. So this particular what you can say restriction allows us to think, makes us think that we must use sliding window technique. And sliding window techniques, what it does is we have a window and we can simply move that particular window to to and iterate to the whole array. But but the question arises, if we have a sliding window and if we have a fixed sliding window, how can we actually observe each particular subarray? Like suppose we have a sliding window of 3. So we are viewing this subarray, then we move the move the window towards right. We have this subarray and this subarray. The question arises, what about the subarray having 4 elements? So we will be using we'll iterate the array again with 4 elements in the window, and so for the 5 elements in the window. But that makes us the question again of the approach again as O of n square, because we are iterating for every size, and hence it becomes n square. So that's also won't work. What we need to observe over here is that if we are fixing the size of the array, the window, we have to create another window for 4 elements. That's what's creating the complexity. So what we can do is, if we expand the window, then we actually can observe that with iteration, with one iteration itself, right? Like right here, if we can expand the array towards right, so we can include 7, or we can include 8, and so on. This way we can actually consider um, basically adjustable sliding window is the idea to it. All right. So, but how do we adjust and how do we observe over here? How will that work? Suppose we are at this point, okay, we have 2, 3, and 4. The product turns out to be 6 into 4, that is 24, which is smaller than k, that is 100. Fine. So let's include the next number, or let's just begin from the very starting in just a minute, starting index itself, that is 160. So 160 doesn't count, the product is exceeding it, right? So we won't be including 160, we will exclude 160 and we'll move on to 2, right? We'll move our window to 2, and 2 is less than k, it's fine. In fact, 2, 3, 4 is the product is less than k, that is 624. And the next step, we will include the 7 value, the right value to it. The window size increases to 4 elements, and at this point of time we can see is the product turns out to be 24 into 7, right? And it's what's 24 into 7? Let me write 24 into 7. 7 for the 28 28, 7 to the 14, and uh, it basically exceeds k value, right? So what we can do is we included the 7 in the window, and the since this product is exceeding, we can start to eliminate the other elements, right? We can exclude the 2. So we can exclude basically 2 from here, from the leftmost side. So the new array which we obtain is 3, 4, 7. All right. So that's pretty much about it, because we are adding numbers from the right hand side of the window, and we are removing numbers from the left side, and that's how we are checking the and that's how we are obtaining the suitable window that is uh, fulfilling this condition. Okay, so add numbers from the right and subtract numbers from the elements from the left. All right. Okay, so let's move to the question and see what we can do right here. Let me just do this. Okay. Um, hmm, just a second. Let me clear it out. I think it's fine. Okay, cool. So we'll begin from the very first index and we'll start from here. We have our window starting from 1. Then let's the window size is 1 right now. So the product is obviously less than 150. So we'll say that this is a subarray that is having product less than 150. Let's include the subarray right in our this space. We'll come back to this later on. Okay, fine. Then will increase our window size to 1 2. Given array, what's that? Given array always be sorted. Question, where's the no. The array is not actually. The array is not sorted because it can be anything. It can be anything for like over here itself. The array was not sorted, and the approach worked. Um, because we are sliding it through, we are including the elements from the right and we are excluding the elements from the left. Okay, so it doesn't matter if it's sorted or not. I've just taken this as an example. Or if you want that, let's include another element that won't be like which is exceeding, let's 200. Okay, yeah, that would be much better. Okay, so the very first interval would be 200, right? Since this 200 is exceeding 150, so we won't be including this, and we'll be moving our window size towards the right. So we'll be moving our window size towards um, let's say 1, because we can't consider 200, it's exceeding the product. Now since the window size is 1, hence when the product in the window is 1, this is less than k, hence we wrote it down over here. Now let's increase the size to 2 elements and include the next element. Now the product is 2, this is less than k, hence include the product over here, 1 comma 2. Okay, fine. So let's now increase the size to 1 2 3. So let's include this array here only, because 1 2 3 is also a subarray which has product less than 150. Okay, now let's move on to the next. Let's move on our slide window and insert the next element, that is 1 2 3 4. So this turns out to be 24, right, to 6 for the 24. Okay, this is also subarray which satisfies the condition, that is less than 150, products is less than 150. Okay, now we'll increment the sliding window towards the next element. and the size of the window becomes 5 elements, and the product is 24 into 5. That is still small because 20 is it small? It's 24 into 5 to 5. That's 120. Yeah, it's small. So we will include that as well. 1 comma 2 comma 3 comma 4 comma 5, right? Okay, so right here what we did is we we included this particular element. Okay, we included this element and we calculated that this particular window is having product less than 150. Okay, and that's why we are including in our set or in our space right now. Okay, let's move our window again and add the next element towards inside the window. So this obviously increases the product, hence we will be excluding from the leftmost side, right? Hence the new window would be this 2 3 4 5 6. Would that decrease the product? No, it won't, because one won't do anything. We will increase the size further, and it's right here. So 20 into 18, 20 into 18 would give us 360. It's still larger. Then we need to move our window, and in such a way that we are excluding the left variable. So we excluded 3. We came out over here. It's 20 into 6. That gives us 6 12, 120. So finally we have this particular subarray that is satisfying the condition, hence we will be including this in our set. This is 4 comma 5 comma 6. Okay, okay, let's move it a little up. Okay, now our window is right here. Let's remove other windows. So the last window was 456, right? So we are going to mark it right like this, and we will include the next element, that is 7, in the existing um, array. In fact, just another thing which I need to show you is right here. If you observe that we had a large array, that is right here, 1 2 3 4 5 and 6. Okay, so after including 6, the product of all the elements exceeded 150, right? So what we did is we started to exclude the elements from the left side. We excluded 1, it didn't change the product, it didn't satisfy the condition. We excluded 2, it didn't satisfy the condition. We excluded 3, it didn't satisfy. And finally, oh sorry, when we excluded 3, then it satisfied the condition because the product turned out to be 120. And when it did, we considered that particular array. So the whole idea is just to exclude elements from the left until we achieve a smaller subarray that is having product less than the k, right? And why we are excluding from the left? Because we need to have a contiguous subarray. So it's just that's how um, customize, or you can say we are changing the size of the sliding window each time by excluding from the left and including elements from the right. So that's how we'll do for the next element as well. We'll include 7 in the subarray, and we'll see if the existing subarray, let me remove this. Yeah, so if we include include the 7 in the sub array. So does this exceed the product, or is it satisfying the condition? So it's 20 into 6, 20 into, yeah. So it basically exceeds the condition. That's why we will be moving our pointer mm, to 840, and 2010 still not done. 10 and 25. Would that work? Oh no, man, not that. I'm just checking what the product would be. Okay, yeah. So yeah. So the thing is, if even after removing 4 and 5, even after removing 4, it won't satisfy the condition. So we have to remove 4, then we have to remove 5, and finally our window size will be 2 elements. That is only 6 and 7, and that will be satisfying the condition. Okay, you can check it out. The product is exceeding. So with that thing said, we can include the array that is 6 comma 7. Okay, and let's just reduce the size, because it's the same thing. Okay, now our last element is present, and we are including the last element in our subarray. Before that, let's remove other. Right. So this subarray is 42 into 8. 42 into 8 into 8 is 366. It's again exceeding it, and 56. Yeah. So right here we have it. It does exceeds the product. Hence we need to remove 6. Okay. And if we remove 6, then we will be then finally it will satisfy the condition. So our window will be 17 comma 8. Then we'll finally include the window 7 comma 8. Now since we have included every element in the window, that's why we will end this particular loop. So this is a loop. Basically we are starting our window from the leftmost side, and we are iterating towards to in the array, and moving our window towards the right hand side. Okay, and we are excluding elements from the left if the product is exceeding the k value, and we are including each time from the right hand side. So we are excluding from the left, and we are including from the right side, and we are checking which is the subarray, and we have these subarray over here. Now the thing is, these are the subarrays which we can observe from one iteration. But there's another thing right here. This subarray has some other subarrays as well, like 1 2, like 3 4 5. Okay, this subarray has 3 4. The subarray, so there contains some further subarrays in the list. So how do we calculate that? So do we iterate towards the whole array again? Actually, we don't need to do that. Why don't we need to do that? Is because you remember I told you about including a right element. Okay, like while we were here, 3 4 7, and we included a right element 7, and we had to exclude this 2 after including the 7. Okay, so what that particular array meant was was that 347 is the subarray that is satisfying the condition having 7 inside it. Okay, so every element, every subarray we generated over here, every subarray which we generated is from including the new element, and the subarray is satisfying this condition. Okay, so what all subarrays are present inside this particular subarray are four. This is also a smaller, because 1 2 3 4 has a product of 3 6 4 24, right? If you consider a smaller subarray that is only 4, the product is 4, that also satisfies the condition because 4 is less than 150. If you consider 3 comma 4, it also satisfies because the product is 12. If you consider 2 3 4, it again turns out to be 24, and 1 2 3 4, it again turns out to be 24. All the subarrays within the subarray are satisfying the condition. So over here, um, we have 4 as a subarray, we have 4 as a subarray, we have 3 4 as a subarray, then we have 4 2 3 4, then we have 4 3 2 1. Right, these are the total subarrays inside a subarray that are satisfying the condition, because obviously lesser elements will obviously make the product less than the whole array. Okay, so that makes us gives us a idea that we can actually calculate the total subarrays by simply observing this thing. So number of subarrays with in a subarray is basically, this is 1 2 3 and 4. That is number of elements in the array. And why is it? Because at to generate each subarray we are including another element, we're including another element, and another, and until we have included all the elements. That's why we have the number of subarrays, our total number of subarrays are 4, which is equal to the number of elements in the array. Okay, so that brings us to a result that to calculate the number of subarrays we need to have that is equal to number of elements. So for here we have four total subarrays. Here we have 5 because the number of elements are 5. We have 3 because the number of elements are 3. We have the total number of subarrays are 2. How to 7, then 6 7, right? So over here we have again 2 because number of elements are 2, number of elements are 3, number of elements are 2, and it's 1. Okay, so what we have, so these are the total number of subarrays. Let's count them up. 4 plus 5, okay, 5 plus 5 is 10, plus 5 15, 15 plus 5 20, 22 is the right answer. 22 is the total number of subarrays that has product less than this. Now let's check it somewhere right here if we can actually edit the. So what was our array? 200, 1 2 3 4 5 6 7 8, and k as 150, right? So let's change any one of it. 200, 1 2 3 4 5 6 7 8, and the value was 150, right? Let's run it, and the first result should be or let's remove other. There's no point of doing them. Let's run it out, and we should get answer 22. This, we got the answer as 22. Yeah, so that's the whole logic. We are excluding from the left position, the left elements, and we are including the right elements. So after yes, I'm repeating the point again. After including a left element, Where should I do it? Yeah, right here. Okay. So after including a next element, like over here, 2, 3, 4 is present, right? And this satisfies the condition of k is equal to 100. Now, once we include the next particular element, 7, this breaks the whole. Um, this doesn't satisfy anymore because 7 is exceeding the product. So to make it satisfy and have 7 in the array, we need to remove some other elements, not 7, because we are checking what is the subarray that has 7 in it. So we exclude 2 from it, and the new resultant subarray was 374. That's why we are including from the right and excluding from the left. Okay, any doubts still here, because that's what the whole approach is, and I showed you it ran correctly as well. Extra braces and array, I'm not sure what you mean. Nice explanation, thanks. Okay. It would be really easy if I had a pen and paper or a whiteboard, because you need to have you need to move a lot over this app board, and it lags also. Okay, so anything, I guess it's clear. All right, shall we move on to the code and compare with the visual explanation? Okay, let's do that. I know it took a little longer, but it will be over soon. I'm almost done. Right, don't worry. Oh, where is the code? Where's the code? Yup. Let's exclude this. Then we have another. Oh, come on. Yes, yes, we are finally over here. We are okay. Fine. So right here, what we have is just a minute, just a minute. What we have here is okay. So the first thing what we can do here is we the this is the whole logic. Okay, inside this count subarray, and it's very small. So we are including the new element. The first at the very first, we are including the new element, and how we're doing is we are suppose we have our subarray. Mm, okay, let's move it right here. Okay, so the subarray was 234. We are including 7. Come on, we 2 3 4. Let's make it a little more closer. So we had 2 3 4. We included 7 in it by multiplying 7 with the existing product, that is 24 into 7, which was greater than k, which was greater than k. So first of all, we included the 7, which is right here. We are the end pointer is right here. Okay, so we included it into our product value. After that, what we need to do is we need to since this value is exceeding 100, so what we need to do is we need to remove elements from the left. That's why we divided the our value p, whatever p was present. So this was p, all right? This was p. So p was existing, that is 234, that was 24 into 7 into 7. Okay. Mm, mm, just a minute, let me clear it out once again. Okay, so P was 24, P was 24, and we included 7 in it. Okay, it exceeded the product, that's why we need to exclude 2. So to do that, we will divide by 2. All right, and hence our, let's change the color, hence we will divide by 2, hence our new array would be 347, and dividing by 2 is done with this particular over here. Okay, P is equal to A divided by start. So what's the start value? So the start value is right here. Okay, so this is going to happen multiple times until we obtain such array that is satisfying the condition. Just like over here, we had 1 2 3 4 5, and we when once we included 6, we had to remove all the elements like 1 2 3, and finally we obtained 4 5 6. That's why it needs to run in a while loop. Okay, so the condition in the while loop is very simple. That is, keep dividing like I did over here. Keep dividing from the very start value until you reach p is greater than k. Okay, so the p value is basically once p value is less than k, then stop this loop. And what about this start is less than end condition? So that's basically edge case. Okay, like right here. So our window is suppose 1 2 3. Up till here it's fine. Once we and our k right here, let's suppose it's maybe 50. Okay, so till here, once our window was 1 2 3, the condition was satisfying. But once we included 1000, the condition break. Hence, not the condition, the it doesn't satisfy the k value. The product is exceeding it. So we excluded 1 from it, and hence our window size turns out to be from here to here, that is 2 2 3000. It also, because 1000 itself is a very large number, so you don't have to, it won't be satisfying the condition. Hence we'll move again, and we'll be okay. So our start value, so each time our window moves, we'll be moving. Why the hell it's okay? Each time our window moves, our start web pointer will be moving a little ahead, and finally when our start pointer will be the reaching the 1000, or that is, it equals to n, then when the end pointer and the start pointer are equal, then we need to make sure, then we need to stop. We need to make sure that it doesn't exceed, so that the start pointer doesn't get forward to after the end pointer. That's why we included this condition. And after that, we are simply checking if p is still less than k. That's why once p is less than k. Okay, so till here, these two conditions, all they did is to find a particular array that is satisfying the condition of k. After that, what we are left out with, after that, what we obtained was a start value and the end value of the subarray. Okay, it's like over here, this is the start value, and this is the end value. This is the start value, this is the end value, And with this particular information, we can actually calculate the total number of subarrays. That is the total number of elements in the subarray. And what's that? That is start position is this one. Okay, so the start value is so for 4 and 6, the start value is, let's me right over here, the 0, 1, 2, 3, and 4. 0, 1, 2, 3, 4, and this is 6. Should take in some other value, but okay. So this is the end value, this is the start value, end minus start plus 1. So this is the fourth and this is the sixth index. This is the, or let's say right here, okay, because this is much clear. Okay, so the index over here was 0, was 1, and the index over the end pointer was 1 2 0 1 2 3. Okay, 3. So 3 minus 1 is 3 minus 1 gives us 2. We need to add 1 also, 1 at the end to make it equal to the number of elements, that is 3 elements. That's why the formula came over here, end minus start, that is 3 minus 3 minus 1 plus 1 to finally make it equal to the number of elements. Now we obtain the length of the array, and then we finally add it to the resultant value. Now we keep on doing that. Now the whole one for loop iteration is basically is uh, is basically figuring out one possible subarray, like this one. Okay, in the next iteration, this particular subarray would be generated, because again we would be adding 5 and we will be making the subarray, and hence we'll be when after that we'll be generating the length variable right here, that is 5, and we'll be adding to the result variable. So this process continues. Each for loop makes out this particular subarray, and we calculate the length and we add it to the result variable. After that we return the result. So that's the whole thing. So any doubt with the code? Okay, so you will be moving to the next question if you don't have any doubt with the code. How we Okay, fine. Ah. So the question right here is subarray with k different integers. Now this question seems a little different. Okay, it seems a little complex and hard, but it's virtually the same question. Okay, I will be just going through the, can I have, I don't have, all right. So the question says is basically we have a array, and what we need to do is we need to find the sub arrays that have uh, distinct integers equal to k, exactly k distinct integers. So every subarray must have exactly k distinct integers, like over here. But how will we find that? And we can see right here, this is the subarray, that is 1 2 1 2, and a subarray of this particular subarray is 2 1 2, that also satisfies the condition. So this is over here, so both of them can be present, Hence, we have to apply a sort of a sliding window technique because we are given as we are need to find out a subarray that is contiguous. Okay, so how can we apply the same concept over here? Is that the idea is suppose suppose we need to find the number of elements which are number of subarrays which are exactly have exactly k distinct integers. Okay, so suppose we have the number of subarrays which have exactly k distinct integers, number of subarrays which have exactly k minus 1 distinct integers, exactly k minus 2, and that comes from 1 1 to 2. Okay, and we have k okay, just a minute, I'll draw this thing and I'll explain. Okay, right here what I've drawn is this particular, suppose this particular area or the section or this k minus 1, it is basically denoting it doesn't denote, it's just a value. So we have these many subarrays, which we have subarrays having k minus 1 distinct integers. Okay, we have k minus 2, we have subarrays having k minus 2 distinct integers. Okay, so if we have um, how should I put this? It's written over here. The count of total subarrays with at most k different integers. Okay, so at most k different integers, what does it mean? Is having sum of exactly k different integers and k different integers plus k minus 1 different integers plus k minus 2 integers. Okay, like it's a little hard to explain, but how should I put this? Mm, all right. So suppose the k value is suppose it's mm, suppose it's basically mm, or okay, fine. So we have a k number, right? We have k that denotes the number of distinct integers we need to have in a subarray. So if we have a total number of subarrays having k distinct integers, let's suppose denoted by n. We have total number of subarrays denoting having distinct integers k minus 1, that is m. Mn o, then and so on, or let's make it okay, having a, then having mm, z z x y z. Okay, yeah, so we are having k having number of subarrays having k distinct integers are z, number of subarrays having k minus 1 distinct integers are y, number of subarrays having k minus 2 distinct integers are x, and so on. We have number of subarrays having one distinct integer are a. So the number of subarrays having at most k distinct integers are x plus y plus plus so on till a, right? Does that make sense? And the number of subarrays having at most k minus 1 distinct integers would be having sum of exactly individual distinct elements, right? Like it's over here is y, x, and so on till a. Yeah. So if we subtract a plus b plus c towards z minus a plus b plus c towards till y, then the answer we get is z. Okay, so the whole concept is to calculate at most k the count of subarrays with at most k different integers minus the count of subarrays having at most k minus 1 different integers. That will denote this. That will give us the desired result. So that's the whole logic. So we can do that. It over here is we can subtract it and we can find it out. So the function which we need to write is finding at most k minus 1 or k at most k distinct integers. Then the count of subarrays having at most k distinct integers. So the question is very similar to that, but we need to have the condition changes, as in earlier we need to figure out the number of subarrays having product less than k. Over here we need to find out the number of subarrays having distinct integer less than k. So the function right here at most k, right, or less than k or at most k is the same. Okay, less than k or at most k is same. So the function is exactly the same. The whole difference is to as in how we change the subarray. Okay, so first of all, right over here, our loop starts from start variable and an end variable. They have a left variable and a left in the this is the code for product question, and this is the code for distinct element question. Okay, so right here we have a start variable and an end variable. Cool. Similarly, we have left variable and the end variable and the right variable. So left and right, and over here are start and end. This we have initialized over here, and over here is left and right. Now here we enter into a for loop. Over here they entered into a while loop. It won't make much difference. Okay, so the first step is to basically multiply. We multiplied to include the right element. Correct. Over here we do the same. Instead of multiplying, we have a hash map. Why we are using a hash map? We are actually having a mm, num to calculate the number of distinct element. Let's dry run this code. It will be really quick, but let me. How do I remove this? Okay. Or let's move it, below. Move somewhere. Oh man. Can't I move it somewhere else? Okay. So right here we have our suppose our given example, and we have a hash map, suppose. So our hash map is basically consisting of, at the moment it doesn't consist of anything. Okay, so right now just look it over here only. Let's look at here only. So the same approach works. We have our index right here. We have our signing window. We are at 2. So what we do is we include the element, and the number of occurrences 1. So this is the key. So this is the key, and this is the value that then denotes the occurrence. Okay, then we include one another next element in the window. For that we'll introduce this one. Okay, sure. I know it's taking a little long, but I'm almost done. Okay, I'm just finished. Sorry for taking this long. It's a little hard to explain. Okay, so we have one in our hash set. We included one, and the occurrence is 1. Okay, we move our window. We include the right element, and hence we update the since. Okay, let's move backwards. At this point of time, we include the right element, that is 2, hence our window is becomes over here. To do that, after doing that, we update the hash value that is 2, because there are two occurrence of the value 2, and then we update the include the next element, hence we just a second, I'm missing something. Okay, fine. Okay, oh, we don't have a current value. Maybe distinct value is maybe, let's say, what was it in the question? The question was having 2. Okay, yeah, so we need to have answer 5. Let's see how it is, then we'll be going through it. Okay, so we have 2. So first of all, we included the element 2, and we have the value as 1. So the size of the hash map, what it indicates is basically how many keys are present. So at the moment, the number of keys are only 1. Hence this satisfies the condition. Hence we have the array 2 beside us, and we will visit it later on. Okay. Now after that, what we have, we move our we move our we increment we include the right element. We include the right element, hence the key value pair is generated 1 1, and over here we again calculate the size of the whole map, which is number of keys present in the map, that is 2. Okay, so it basically is at most 2. It was at most 2, hence we included this array also, because it's satisfying the condition that it must be at most. Okay, all right, fine. So at most, then after that, what we did was to have another right element included right here. So with that, what we did is we updated the value to 2, because there's another 2. Again, the size of the hash map is 2. Hence this array also satisfies. Hence we will be including 2 1 2 also in our answer array. Okay, let's move on to the next value, that is 2 1 2 1. Okay, now again the value becomes, we increment the hash value. Same goes for this thing, like it should be as it something different. Okay, so we'll be including 2 1 2 1. Fine, we have our sorry, just a minute. Okay, we included the 2 value. Okay, so we updated the uh, it should actually contain the value 2 1 2, and then we have another array, that is another element in the array, that is 2 1 2 1, and we turned out to be 1 2. Then we have one. Then we have, because the number of keys are same, that is the distinct value are 2, and it's at most 2, then it satisfies the condition. And then we start to include the last value as well, with this we have 6 and this 1. Now the size of the size of the hash map is 3. Hence this is exceeding the size. What we'll do now is we will start to remove from the left hand side. Come on. Okay, yeah. So so the array was this, and we if we exclude 2, we come over here and we update our value to 1. Still the size is 1, still the size is 3. It won't work. So what we need to do is we need to update, we need to make our window a little smaller. Okay, still doesn't work because the size is 3. Okay, we have 3 keys, this denotes the size. Okay, we need to reduce our window. This becomes 0, and we finally, since the value is 0, we finally remove it, and now we calculate the size. It becomes as 2, and hence this satisfies the condition, and hence we'll be including as uh, damn it, yeah, 1 comma 6. And we are finally done with these elements like we obtained in the previous example. Okay, so this is the having at most k distinct integers, right? And it can also have a subarrays. Hence this particular, as as per the previous logic, we need to calculate the length of the array. This is 2, this is 1, this is 3. Okay, why we are doing so is because we are calculating the possible subarrays. That is this subarray that also satisfies the condition, that is this subarray satisfies the condition, this subarray that satisfies the condition. Okay, so the same thing. That's why we need to calculate the no, length of the value, the subarray. Okay, 2, 1, 2, 3. So this becomes as 1, 2, 3, 4, 5 plus 5, 10 plus, so it's basically 12. So this is basically 12. This is, so the have distinct integers with at most k, at most 2. All right, at most 2 is basically is basically is basically 12. So that's what was function of at most 12, at most k. This was 12 minus at most of k minus 1. And if you repeat the process for k minus 1, that is k was 2, hence k minus 1 is 1. So if you repeat the whole process, it will turn out to be exactly 6. And how we can see over here, 1 is basically 2, 1 is basically 2 1, and something like that. So if you just go for the same approach for k minus 1, you will get the answer as 6, and 6 minus 12 is equal to 5. That's how the 5 value came. All right, and if I can show you the number of subarrays, and let's see if this works. Let's see if we can get 12 answer. Okay, at most k, we want to see what's the value of at most k. Okay, so before returning the count, what we'll be doing is we'll be printing out. So this is the same logic. Okay, so we'll be printing out cout. Cout, what was the count? Okay, yeah, the count. Okay, let's run the code, and above 7 we must get. Now is it the same value? is it showing 7? Yeah, see, right here it's 12. Okay, so the like you can, it's 12. Sorry, this must be 5 actually. So this must be 5 actually, or whatever it is. This, the thing is, this is at most k is 12 and at most k minus 1. So this function is called 2 times for k and k minus 1. So for once the k function was called for k value, it printed out count and the count was 12. And once the function was for called for k minus 1, it printed out value 5. Okay, so and we subtracted it. That's how it's done. And just quickly going through the whole code and comparing it with that. So thank you guys for staying so long till so long. Okay, I'm just almost done. I'm just covering it up because it will go on YouTube, so I have to cover it as well. I'll provide the link to the YouTube channel also. Okay, so over here, yeah. So what we did is we multiplied. Last week have been, yeah, I have uploaded it. I'll provide the link. Provide the link. So right here we have our okay. So we have a for loop. Okay, we have a for loop and we calculate each possible subarray. So right here we do the same with while loop, and we make sure that the right variable doesn't exceed the array. Over here we did with n variable less than n. Same thing. Now there's an if condition, or not exactly if condition, but really this adding of in integer in the hash set, just like we did with the product, because over here we need to make sure, we need to observe the number of distinct elements, hence we updated the hash value. But in the product question, what we did is we multiplied the existing product with a new value. So that's the whole thing, just difference of what we need to do. And is this if condition is just to check whether the value already exists or not, like the two all did, like two over here, two over here in the hash map existed or not, and we introduce a new two. Okay, that's what the whole thing is about. So if it doesn't exist, we create a value 0. Otherwise we simply increment the value. Okay, otherwise simply incremented the one value to 2 or something like that. And after that we come on to the while loop over here. That is basically like basically excluding elements from the left till we obtain a subarray that is satisfying the condition. Same goes for here. We are checking the map size that I mentioned right here. We are checking the map size over here. That gives us the number of keys. Okay, we don't care about the value. Okay, value will be decremented each time we exclude a number. Each time we exclude number, so value will get decremented, and once the value becomes 0, then the final key will be removed. And the whole meaning of that is, even if one occurrence of that value is present, that counts as a distinct value, right? Until the key 2 becomes 0, I mean it doesn't exist in a subarray. That is the point what we need to achieve. Like we need to remove 2, and the subarray finally became 1 and 6, and that's what gave us a result as 2. Right, so that's what happening is over here is we are checking the size, and when the still until the size is less than k, right? So since it before it was 2, the size was 3. When it became 1, the size was 3. When it became 0, then finally the size became 2, because the only elements were 1 and 6. So the only elements were 1 and 6, right? That's why we are comparing map.size. And at last, what we are inside we are doing is, yeah, uh, we are doing it till the size is less than k. And this particular statement, all it does is reduce the value. Okay, and if and else, and you can see right here we are dividing it and moving the start pointer towards the right. I mean, excluding the left variables. Same over here, we are excluding the left variables. Okay, so that's what it's going on. And once the whole thing is just excluding the elements until the size of the map is satisfying. That is, becomes less than k, less than or equal to k. And when that happens, we'll simply use the same formula that we used over here, n minus start, that is right minus left. So over here, the it is end. In this question, it is right. This is the same thing. And then finally, um, incrementing the right plus plus. And why is it writing right plus plus? Because this is a while loop, and over here the end value is incremented in the for loop itself. But since in this code they have used a while loop, the right value is incremented explicitly by writing over here. See, in the for loop, the end value is right is incremented right here. It's the same logic, exactly same logic. Everything is same. Just there is a difference of start less of not including this statement is because the k value won't be less. Like, there's no meaning of finding out k is equal to 0 with no distinct elements. It has to be 1. And even the single subarray subarray having a single element, I mean, the start and end pointer won't go forward, because when they come together at the same point, it does satisfy this condition, because the only element present is 1, and that's the distinct element. Hence, we don't need to worry about this particular condition. Hence, we exclude it from here. Okay, so that's what it was. And other thing was, yeah, just the map. We used map. Just a summary is over here. We included the right elements and incremented our map, added the values, and then finally we are erasing the left values so that we can actually obtain the size of the subarray, that contains the distinct integers equal to at most k. And finally, we are using in the count variable. That's what the whole question is about, and it's pretty easy. You can do it now, I guess. I don't think anyone has any doubt. You can read it out, and it would be much clear now. I think I have commented something right here. Yeah, so there is a right minus left plus one. Someone asked how is this working, so I explained it right here only. Is because if we include one in the previous array, then we can generate all these subarrays. All right, and if we have a right pointer and the left pointer pointing, like, if you have a right and left variable, we can actually subtract right. Uh, we can actually do right minus left plus one to obtain the number of uh, subarrays possible. That's how right minus left is working. Okay, that's the whole explanation to it. And that we were supposed to discuss those questions, and we are done with that. I know it took a lot of time. Sorry for that, and thank you so much for staying till now. Yeah, I will watch it again, sure. In this problem, can't we do without hash map? See, like, the question is to find the distinct elements. If you do it without hash map, you have to, like, how will you check the number of distinct elements? You have to check it somehow, right? So if you check it iteratively, like you will go again and again to check the number of two or number of one in the particular array. Okay, right here, if you check the number of, it was the, yeah, so over here you went on, if you keep on checking what are the number of twos or what are the number of ones every time you go for sub array, it will obviously increase its complexity. Hash map is really useful to um, reduce the time complexity. Okay, so that was it. Any other doubt before moving on, before finally concluding this session? In two sum problem, cannot we use two pointer? Cannot we use two pointer? Two sum, yeah, I've done that question as well. Okay, I think Chinmay wants to, I mean, Chinmay, okay, I'll provide the link as well to the YouTube channel. But before that, let's discuss the two sum problem. Two sum problem, what's the two sum problem? We need to find the sum of the two values. Uh, Agreed to. Yeah, two pointers technique. You can use two pointer technique when the array is sorted. Okay, so when in the two sum problem, the array when it is sorted out, that is, suppose, right, it's um 2, 7, 11, and 15. Okay, so once the array is sorted, then you can use two pointer technique because you are sequentially, so one pointer will be at 15, one pointer will be right here. How did this happen? Okay, one pointer will be right here, and another, just let me draw it right here only. Okay, so we have 2, 7, 11, and 15. So you have one pointer right here and one pointer right here. So you are seeing whether the sum is the required sum or not. And if it's not, if it's exceeding, you will decrease it over here, decrease from here. And if it is less than the required sum, you will increment it. And the reason for doing is because the only option, because this value is smaller, you're adding these two elements, right? And since if the sum is less than the required sum, you need to add a larger value. So that's why you're incrementing the pointer. Okay, so the whole approach of two pointer works if the array is sorted. But if it is not sorted, then you have to use hash map to reduce the complexity. Using a hash map would be simply checking whether the element already exists or not, like that. Just see the video, you can do that. I hope that clears it out, Sohana. Okay, I
Hello,
suppose.
hello,
Yeah.
hello. You said that map is not sorted. We will sort the map, then we will use the two pointer approach.
Sort the map. Okay, let's just do this.
Yes.
Let's okay. Let's just do this over
मतलब
here.
sort the array. Sorry, sort.
Sort the array. Yeah. So we can
If
sort
it
the
is
array.
unsorted,
Yeah, we can sort the array. Again,
then
we
we
need to have a better complexity solution, right? This solution is n log n. And if you have a hash map, you will create a space and then you can actually solve it in n of n because you're referring each element once. Right, in the hash map,
okay.
these elements are present. So what you can do is directly check whether the counterpart of this is present or not. Okay.
Sir, I have another query that in C program map is not used. So how can we do that? Do that problem?
Okay, C, yeah. So in C++, there is a there is an option
C.
of using. map. But
Yeah,
in C programming language, they don't. What you can do is you have to create a map manually. They don't have any inbuilt function. That's why C++ is much better. So what you can do is you can just create an array, all right, and an array, and in the array you can actually in two-dimensional array actually. So in the array, if you come across a value 7, suppose this row will act as a key and this row will act as a value. So if the value exists two times, then you will make the value 2, and you can basically check it out. Or instead you can have a single array having indexes as the key, right? So if you come across the array as, suppose in the array there are 4, 3, and 4, suppose. So you came across 4, all right. So what you did is, in the array, you made this array yourself. In the array, you incremented the value towards 1. You saw this 4, and you saw this 4 again. You incremented the value to 2. You saw this 3. You incremented the value to 1, and so on. You have to manually allocate a space of for the array, and you can update the values accordingly. There are multiple ways you can have a two-dimensional array, right? Basically, just to keep track of whatever elements, because in the array it's very easy to access 4, right? Is it, it is O of n, O of 1. It takes O of 1 time to access this particular element in the array. That's what map is. Accessing becomes easier, so you can do that with array. Google this stuff out and you can find how to implement map in C programming language. Okay, and it's better if it's better to switch to C++ if you are if you want to use the inbuilt
no, I'm
function.
doing in Java.
Okay, yeah, you can do it in Java only. That's hash map, right?
I'm doing in Java.
Hash map is also available in Java.
Yes,
Hash
yes.
set, hash map. So that clears it out. Anything else?
Actually, I have asked this question because uh, actually I have asked that question because if interviewer asks me the you can do that problem without hash map or map, then how can we do? Then how can I do? That's why.
Actually, the thing is that hash map is a data structure, right? So if you are using a hash map, that's a data structure that you're using to solve the problem. Usually, interviewers don't ask you to uh, rebuild the whole data structure. Okay, so they assume that there exists a hash map and you can finally easily use it. But what they are interested in, how you are using it in the question and how effectively it is getting used. But in some case, in a rare interview, if they do ask, you can say the whole logic remains the same, but I'll implement the hash map in the background using an array, like I mentioned over here, using an array like this, updating the values. Okay, you can say that. Okay.
Okay,
Anything else?
okay. No,
Fine, fine. Okay, let
um,
me show you the YouTube channel. Okay, I think Chinmay is waiting for that only. Okay, so I have named that channel as Dream FAANG. Okay, I have named it such a way because it looks attractive. Okay, this is the channel. So till now I have included the discussion of mm, 2 weeks. Okay, you can Google that.
No, actually, I was waiting for the explanation only. What we
No issue, no issue. So you can go to that channel and let me provide the link only.
So you will be editing these videos, right?
See, what
Are
I
you
have
putting the
done,
whole?
what I
Hello.
have done is
Suppose this pointer is
basically,
J.
Hello.
yeah. Am I audible? Hello, 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 hello. My voice is
Are you
going.
putting the whole video or you are editing it?
Am I audible? First of all, tell me, because I don't
Yes.
think.
Yes.
Yeah, okay, sure. So I'm putting
no,
the entire video, but what I'm doing is I'm introducing
Yes.
the timestamps. Okay, so in the if you want to visit this particular question, you can click on
Okay.
this point. All right. So that's how things go. And it becomes easier to navigate and look at particular question. You can even
Okay.
increase the speed of the question of the video, so that usually every problem takes around 20 to 30 minutes, so that way you can speed out the.
Um,
Okay,
Yes.
so just
Okay.
go to the
hello, hello,
dream.
Yes.
Yeah.
Thank you.
hello.
Okay, let me share the link as well before going on. Yes, Wana, what do you have anything to say?
Yes, sir. Actually, I have another problem. If you don't mind,
Okay, fine. We are doing it. It's okay. Just tell me. Chinmay, you can leave because
uh,
we are almost done with the discussion. If you want to say, you can. I'll provide you the link as well. All right, Swana, tell me what the problem is.
yeah, the problem is largest array with sum 0.
Uh, largest Subarray
Largest array with 0 sum.
with zero sum. Okay, let's open this. Yeah, I found that question. This one, right? Largest Subarray with zero
Cannot
sum.
be,
So, what's the issue?
cannot we do that problem using binary search?
Yeah, you have to find the length of the largest subarray. So, length of the subs binary search is finding one element, right? Binary search is
Uh,
excluding these kind of certain elements and then moving on to some sub portion. I'm not sure how will you implement that in this question.
uh, एक्चुअली मैंने जो अप्रोच किया था कि मीड वैल्यू निकालूंगा, मीड वैल्यू मेरा -8 में होगा, फिर मैं लेफ्ट से लेकर मीड तक मैं सम कर दूंगी, देखूंगी कि उसमें जीरो है कि नहीं, अगर जीरो है तो उसके लेफ्ट से लेकर मीड तक मैं उसका इंडेक्स में रिटर्न कर दूंगी, अगर फिर देखूंगी कि मीड से लेकर राइट तक की वैल्यू पूरा सम करके जीरो आ रहा है कि नहीं है, तो वो मीड से लेकर राइट तक का इंडेक्स मैं निकालूंगा, ऐसा नहीं हो सकता क्या?
Okay, it's an interesting solution. So what you're doing is, uh, mm, you're taking the mid value, you're calculating the mid value, right? पहली बार. So first of all, you are summing it.
हाँ,
पूरा sum निकाल रहे हो. पहले पूरा sum निकाल रहे हो. If it is zero, then you will return
नहीं,
that.
लेफ्ट से लेकर मिड,
तो मान लो पूरा
यस,
sum zero होता है
मतलब
ना.
मैं मिड वैल्यू निकाल रही हूँ तो
Okay,
हम्म,
okay. So first of all, if you find out that the whole array is having some zero, so you'll return that. Then what we will do is mid value निकालोगे. ओके, मिड वैल्यू निकाला और मिड का एक साइड, और
हाँ,
कौन सी
मिड
साइड
वैल्यू
में,
निकाल,
अब ये कैसे पता लगा कौन सी साइड में जाना है? ये कैसे पता लगेगा तुम?
एक मिनट, मैंने जो अप्रोच किया कि मैंने मीट का निकाला है, ठीक है, तो मीट मेरा -8 पॉइंट करेगा, ठीक है, मैं देख रही हूँ कि लेफ्ट में 15 है और राइट 23 है, तो लेफ्ट से लेकर मिड तक मैंने -8 तक मैं प्लस करूंगी, देखूंगी कि उसमें जीरो आ रहा है कि नहीं, अगर जीरो आ रहा है तो मैं उसका इंडेक्स निकालूंगी लेफ्ट से लेकर मिड तक, फिर मिड से लेकर राइट तक मैं काम करूंगी, देखूंगी कि मैं उसमें जीरो आ रहा है कि नहीं, अगर आ रहा है तो उसका मैं इंडेक्स रिटर्न करूंगी मिड माइनस राइट +1,
ठीक है, अगर मान
ऐसा
लो नहीं
करके।
नहीं मिला फिर? अच्छा, वैसे फिर फर्दर इनटू अंदर जाओगे. बट मान लो सपोज
हाँ,
सपोज मानते
हाँ,
हैं कि यू चेक्ड फ्रॉम दिस पर्टिकुलर सब एरे, ठीक है, तुमने इसका सम निकाला, इसका सम जीरो नहीं आया, ठीक है, यू विल चेक द अदर सब एरे, राइट, उसका
हम्म,
सम भी जीरो नहीं आया. तो
हम्म,
अब इन दोनों में से किसके अंदर जाना है?
हम्म,
बाइनरी सर्च
हम्म,
में एक एलिमिनेट होता है ना.
तो -1 रिटर्न करूंगी।
अरे मान लो ऐसा भी तो हो सकता है ना कि इतना
हाँ,
छोटू या बीच वाला एलिमेंट भी जीरो हो जाए. जरूरी थोड़ा ना कि बड़ा में अगर खत्म हो गया तो अंदर छोटे में नहीं हो सकता, समझ रहे हो? लाइक अगर ड्रॉ करके मैं बताऊं, इफ यू वांट,
ओके।
करो
हाँ
ड्रॉ।
हाँ।
ठीक है रुको, लेट्स डू इट। 15, फिर क्या था, मे बी 2 2 8, ठीक है, और माइनस, इनफैक्ट अच्छा 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 अच्छा, फाइन 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 फाइन, या फिर या फिर ओके, शायद हो सकता है, शायद हो सकता है। लेट्स डू, चेक इट आउट। माइनस,
मैंने एक्चुअली ड्राई रन करके भी भेजा था, तो रिप्लाई नहीं दिया, इसलिए बोला था।
क्या ग्रुप पे भेजा क्या?
हाँ हाँ हाँ।
अच्छा अच्छा अच्छा, okay, so there are like so what you're doing is you are taking some of this and some of, okay, तो सी जीरो आ रहा है, मुझे जीरो नहीं चाहिए, नहीं लाना है, नहीं नहीं जीरो नहीं है, जीरो आ रहा है, आ रहा है। तो हाँ देखो, सपोज तो सबसे पहले तुम क्या करो, सम ये करो तुमने, ऑब्वियसली जीरो नहीं आएगा, बहुत बड़ा है,
हाँ
ठीक है। फिर उसके बाद तुमने क्या किया कि सम, इसका
हम्म,
सम किया, इसका सम जीरो आ रहा है, जीरो नहीं आ
हाँ
रहा, बिकॉज 8 - 8 इज जीरो। नाइस, बट फिर उसके बाद तुम 7 और 20 करोगे तो 27 आ रहा है टोटल सम। बट तो तुम
हम्म,
तुम्हारे लॉजिक के साथ तो तुम तो रिटर्न कर दोगी, लेकिन यहाँ पे एक सब एरर छोटा एग्जिस्ट करता है।
मैं शॉर्ट करूंगी, आई थिंक मैंने शॉर्ट ही किया होगा। एक
अच्छा,
मिनट, मैं प्रोग्राम भेजती हूँ आपको।
तो रन कर रहा है, वो चल रहा है क्या?
टाइम एक्सीड लिमिट दिखा रहा है।
अच्छा ठीक है, प्रोग्राम भेजो, कहीं कुछ कोई लिंक विंक है, किस में चला है, गीक्स हो गीक्स?
हाँ, गीक्स और गीक्स में चलाया था।
अच्छा, तो
एक मिनट,
कोड शेयर करने आता है?
एक मिनट, एक मिनट।
Damn, this it take it almost 2 hours.
सॉरी सर फॉर दैट।
कोई दिक्कत नहीं, कोई दिक्कत नहीं, हो ही गया। Like I'm really interested. I'm really impressed that you stayed till right now. So अच्छा, जनरली सब चले जाते हैं।
सर इंटरव्यू के लिए करना पड़ता है, एक्चुअली मैं फाइनल ईयर।
ओके ओके, ठीक है। I'm glad that you are liking this whole setup. ठीक है। After this, I'll upload the material for
ओके,
week 4.
मैं आपको मतलब चैट में भेज दूंगी, अगर कोई प्रॉब्लम नहीं, टेलीग्राम में।
ठीक है, क्या क्या भेजना है?
कोड भेज दूंगी, अगर आप समझने में प्रॉब्लम आ रहा है तो।
अरे सी प्लस प्लस में ना?
सी प्लस प्लस में नहीं, मैंने जावा ही किया है, बट जावा से ही किया है, आप समझ
जावा
जाओगे।
मुझे आती है, वैसे कोई इशू
मैंने
नहीं
कोई
है।
मतलब हैश मैप यूज नहीं किया मैंने।
अरे बाप रे, ये कौन सा टू सम प्रॉब्लम है? अच्छा
टू
ठीक
सम
है,
प्रॉब्लम नहीं, ये वाला प्रॉब्लम है लार्जेस्ट सवेरे विद सम
राजस्थान,
टू।
ओके ओके ओके, जावा, ओके, नाइस नाइस। तो जीएफजी इसमें तो रन नहीं करेगा, हट यार। जावा में जाओ, आ, इसमें तो क्लास ही रिटर्न करी ना तुमने बस, फाइन, और उसमें कुछ इनपुट इनपुट देना है, अपने आप चला जाएगा, या मेन फंक्शन कहाँ है इसका?
मैंने नहीं ये, हाँ
मेन फंक्शन ही उड़ा दिया। अरे फुल पूरा कोड दो ना यार, मतलब मुझे फिर लिखना पड़ेगा, डायरेक्ट चेक करेंगे वहां से, आधा आधा।
पूरा कोड ही तो मैंने आपको भेजा पूरा।
अच्छा चलो ठीक है, रुको, अब कैसे करूँ, रन करूँ, ये चल जाएगा या फिर कुछ और करना पड़ेगा ऐड इसमें, मैक्सिमम लेंथ?
हाँ नहीं, फिर ऐड तो नहीं करना पड़ेगा, चल जाएगा आई थिंक।
नहीं चलेगा इसमें
चल जाना चाहिए।
अरे रुको रुको, जस्ट अ मिनट, मेन फंक्शन लिखना है, एंड
इसमें
मेन,
इसमें ये दिखाएगा
अरे पब्लिक स्टैटिक मेन होता है ना जावा में, तो जावा में तो पब्लिक स्टैटिक मेन होता है, वो पब्लिक होता है, वो सब कहाँ?
हाँ हाँ हाँ, वो नहीं, अपने नहीं देखा, सर ये देखा नहीं मैंने।
पब्लिक स्टैटिक void, so we can,
void में
ठीक है। और अंदर कुछ होता है क्या? अंदर भी तो कुछ होता है, स्ट्रिंग करके होता है, याद नहीं आ रहा मुझे, स्ट्रिंग या आरजीएस,
string ARJS
और ऐसे करके भी होता है।
आपने ब्रैकेट नहीं लगाया? हाँ ब्रैकेट।
फिर उसके बाद और क्या होता है, और फिर हमें एक एरे को पास करना है ना, तो लेट्स मेक इट
फंक्शन कॉल,
तो पहले
हाँ
एरे एरे
मतलब
तो बनाना पड़ेगा। और इस फंक्शन का भी कुछ भी होता है ना, पब्लिक लिखना होता है, पब्लिक स्टैटिक और इंट, बस यही होता है। ओके फाइन। और फंक्शन में पहले एरे बनाते हैं। एरे कैसे बनते हैं जावा में, ऐसे ही होता है क्या? हाँ ऐसे ही होना चाहिए। व्हाट्स इन द एरे?
न्यू
हाँ
इंट।
न्यू इंट, न्यू,
अच्छा आपने सॉरी,
मैं भूल गया यार कैसे बनाते हैं जावा में एरे।
नहीं नहीं नहीं, आपने वैल्यू ले लीजिए 15 12 जो वैल्यू
अच्छा
है।
अच्छा अच्छा, ओके ओके ओके, 12 2, फिर 20, then what was the value, 8 minus 8, 8, and then finally was, oh, come on, 2 220, okay fine, 2 2 and 11, fine, this was the thing, and we are calling the function that is, okay, और इसमें
वैल्यू ले लीजिए। एरे मैक्स एरे में क्या था?
system
एरे
dot
और
out,
एन।
system dot out dot print,
डॉट प्रिंटली,
um,
आपने सिस्टम डॉट आउट दो बार ले लिया, सिस्टम डॉट आउट डॉट प्रिंटली। हाँ
और बस यही
ए
होता है
आर
ना,
आर ले लीजिए, ए आर आर, हाँ ए
कॉमा,
आर आर कॉमा, एन तो नहीं, एन
कितना,
एन
एक
एन
दो
क्या?
तीन चार पाँच छः सात आठ, आठ आठ वैल्यू, ठीक है। ये करते हैं, चलो
हाँ
रन करते हैं, जय माता दी। नो आउटपुट, कैन नॉट फाइंड सिंबल, एरे सॉर्ट, ओके। तो मैं क्या, कैसे करते हैं, कुछ इंक्लूड करना होता है क्या इसमें?
नहीं, एरे सॉर्ट ही तो हाँ, इंपोर्ट जावा डॉट यूटिल आपने दिया है क्या?
नहीं दिया, मुझे थोड़ी याद आएगा। import डॉट जावा डॉट यूटिल
यूटिल डॉट स्टार्ट,
डॉट
हाँ
स्टार, कोई नहीं। By the way, is it recording properly? Yes, it is, and मज़ा भी आता है कभी कभी करने में। Come on, रन ही नहीं हो रहा, अरे ये क्या, तो टाइम लिमिट दे रहा है क्या?
ये बहुत टाइम लिमिट दे रहा है इसलिए।
कोई ये चीज़ को ना किसी और पे रन करके देखते हैं। जस्ट अ सेकेंड, भी जावा का पब्लिक स्टैटिक माई क्लास है ना, माई क्लास, क्या क्या है आंसर? मैक्सिमम, अच्छा अच्छा है, वी लोड फंक्शन, ठीक है, कहीं ना कहीं लूप घूम रहा है तुम्हारा भाई, फिर इसका ये मतलब है।
हाँ मैंने जस्ट ये किया कि मतलब मीट लिखा रहा है, लेफ्ट से लेकर मिड तक प्लस है, उसका मैक्सिमम में कितना आएगा, 0 आएगा या कुछ और आएगा। तो इंडेक्स रिटर्न कर रही हूँ और की स्पेशली।
ओके, सेम यहाँ पे भी DL ही आएगा, ऐसा कुछ खास फर्क नहीं है, बट यहाँ देख लेते हैं कि क्या किया तुमने। एक तो यार कमेंट थोड़ा और करना चालू करो, बिकॉज उससे क्या होता है कोड बहुत क्लीन लगता है, और मुझे जैसे आई एम लुकिंग इट फॉर द फर्स्ट टाइम, सो इट बिकम्स ईजियर फॉर मी टू सी थ्रू इट। ठीक है, जितना शॉर्ट मतलब इस द होल आइडिया कि
मैं
सामने वाला
कमेंट
कैसा
कर।
समझ सके। ठीक है, कम से कम लाइन में जितना हो सके वो ज़्यादा अच्छा रहता है। वैसे द फर्स्ट थिंग यू आर सॉर्टिंग द एरे, पर सॉर्ट क्यों किया फिर? जो तुम्हारा जहाँ बाइनरी सर्च वैसे ही
हाँ
काम
मैंने
करेगा,
sort किया।
बट सॉर्ट का कुछ
हाँ
समझ नहीं है, मतलब कुछ यूज तो होगा नहीं सॉर्ट का। सॉर्ट से यार एक और, हाँ सॉर्ट करना इनफैक्ट गलत रहेगा, बिकॉज तुम अगर
मैं
सॉर्ट
sort
कर दोगे तो फिर तुम्हारा सारे वैल्यूज जो होगा वो इधर उधर हो जाएंगे ना, तब तो इंडेक्स का मतलब ही नहीं रहा। तब तो मतलब लाइक जैसे मान लो
मतलब
सब
शॉर्ट ले लो।
सब एरे
हाँ
सपोज यहाँ है, ठीक है, सब एरे, इसका सब एरे का लेंथ कितना है, 2 है। आफ्टर सॉर्टिंग क्या होगा,
हम्म
-8 सबसे पहले आएगा, फिर आएगा 2 2
हम्म
7 फिर 8, और फिर बाकी
हाँ
सारे जैसे 20 और 15 और 20
हाँ
आएंगे। तो इस बार इसमें सब एरे सॉर्ट करने के बाद फिर सब एरे तो रहा ही नहीं
हम्म
वो। 8 और -8 तो अब तो कभी
हाँ
कब जीरो तो हो ही नहीं पाएगा, बिकॉज जैसे ये 8 और -8 आएगा तब बीच में 2 और 7 आ गया। तो सॉर्ट करने से तो क्वेश्चन ही बदल गया। तो पहली बात, तुमको सॉर्ट नहीं करना है। ये मतलब नहीं है अगर बाइनरी सर्च लगा रहे हैं तो वो उसमें सॉर्ट ही करना होता है। बाइनरी सर्च तब लगाते हैं या सॉर्ट तब करते हैं जब हमें ऐसा आंसर चाहिए होता है जो कि एरे के पोजीशन पे डिपेंड नहीं कर रहा। जैसे अभी क्या पोजीशन पे डिपेंड कर रहा है ना, इनिशियली हमको ये दे रखा है, तो डिपेंड करता है। अगर हम थोड़ा भी हिला देते हैं
हम्म
चीज़ों को तो ये 8 कहीं और चला जाएगा, फिर वो सब एरे में 0 देगा कि नहीं कुछ नहीं पता, क्योंकि जैसे ही
हम्म
8 -8 कहीं पीछे जाता है तो बीच में कुछ और एलिमेंट आ जाते हैं, वो 0 देगा कि नहीं सम कुछ नहीं कह सकते हैं। इसलिए प्रॉब्लम है, इसलिए सॉर्ट करना सही नहीं रहेगा। तो तुम्हें बाइनरी सर्च ऐसी ही लगानी पड़ेगी, बिना बिना करके, उसके बिना देखते हैं। ठीक है, तो फिलहाल इसको अभी से हटा देते हैं। ठीक है, और ये फिर भी टाइम आउट देगा बिकॉज हुआ है।
हम्म
तो
और
सबसे
हाँ टाइम आउट। और एरे डॉट लेंथ इज इक्वल टू 0 जैसे कि मेरे एरे मतलब एरे में एक ही वैल्यू रहा पर नहीं वैल्यू नहीं रहा तो रिटर्न 0 करेगा, कुछ भी नहीं रहा तो।
ठीक है फाइन, तो या इसमें लिख
मतलब
देते हैं।
कॉर्नर केसेस।
हाँ रिटर्न, हाँ इफ नो और सिंगल वैल्यू। ठीक है, ये वाला कर दिया। फिर उसके
और
बाद तुम्हारा
एरे में
लेफ्ट और
एक
राइट
वैल्यू
है।
रहा जैसे कि हाँ
लेफ्ट और राइट, तो हाँ वो रिटर्न कर देगा, बिकॉज रिटर्न 0, बिकॉज नहीं फिर उसमें भी सम करना पड़ेगा। मान लो वैल्यू 0 हुई, फिर तो सम 0 आ रहा है, तो रिटर्न
हम्म
कर देंगे 1, है ना। तो वो अलग केस रहेगा।
अच्छा हाँ
सिर्फ द लेंथ इज 1। तो इसका एक तरीका होता है कि जैसे आई डोंट नो तुमने कितनी बार इस कोड को वापस रिव्यू किया होगा, बट वंस यू राइट दिस कोड ट्राई टू गो थ्रू इट अगेन एंड अगेन। ठीक है,
हम्म
सो इफ इट इज 1 सपोज, एंड इफ इट इज 1 तो हाँ, तो क्या क्या बोल रहे थे, इफ द वैल्यू, इफ द एरे ऑफ 0।
जैसे कि अ, हाँ एक वैल्यू रहा तो उसमें मेरा मतलब 1 करेगा या 0 करेगा, जो इंडेक्स रिटर्न करेगा आई थिंक। नहीं इंडेक्स नहीं, वो उसमें एक वैल्यू रहा तो -0 0 तो नहीं हो रहा है।
लेंथ रिटर्न करना है तो 1 रिटर्न करेंगे,
हाँ
है ना, बिकॉज ये इंट रिटर्न कर रहा है तो लेंथ रिटर्न करना है ना, लार्जेस्ट। तो लेंथ
हाँ
ऑफ द लार्जेस्ट एक ही वैल्यू है, तो एरे कितना साइज का हो, 1।
हम्म
बहुत मैसेज आ रहे हैं यार तुम्हें। रिटर्न 0, ठीक है, ये समझ आ रहा है ना क्या है, कि अगर मान लो वैल्यू 0 नहीं हुई, ये वैल्यू क्या हो रहा
हम्म
है कि इफ दी, सॉरी कमेंट कर देते हैं, इफ दी ओनली वैल्यू इज नॉट 0, इफ 0 then uh, return length is 1 else 0। लेंस रिटर्न 1 और एल्स 0। ठीक है, जो अगर ओनली वैल्यू जो पहली वैल्यू है वही 0 है तो लेंस 1 रिटर्न करेगा, अदरवाइज लेंस 0 एंड 0 आते हैं 5-10 मिनट करे करे। एक मिनट, जस्ट अ मिनट, सॉरी कोई आ गया था। ये क्या, लेंथ इज इक्वल टू 0। फाइन, नेक्स्ट वी मूव ऑन टू द लेफ्ट पॉइंटर और राइट। तो तुमने क्या किया, 2 पॉइंटर ले लिया, ठीक है, और मैक्स लेफ्ट। देखो बाइनरी सर्च यार वही होता है कि एक्सक्लूड कर रहे हैं कोई एक कंडीशन पे। बाइनरी सर्च बस उतना होता है, इट डजंट मीन यू हैव टू चेक अ मैक्सिमम वैल्यू और उस हिसाब से तुम लेफ्ट राइट मूव करोगे। ठीक है, लेफ्ट छोटा हो गया, ऐसा हो गया, मिड की वैल्यू है। अगर मतलब कोई एक कंडीशन पे हम लोग आधी वैल्यू को छोड़ते हैं, बाइनरी में वही होता है ना कि आधी वैल्यू एक्सक्लूड कर रहे हैं, तो वो एक कंडीशन पे करते हैं। तो तुम्हारा अप्रोच वाज कि बाइनरी सर्च यार इसमें अप्लाई पहली बात हो ही नहीं पाएगा, बिकॉज अगेन इन द सब एरे, या चलो ट्राई करते ही हैं कि अगर इसमें इतना आ गए हैं यहाँ तक तो करते ही हैं। तो लेफ्ट और राइट तुम्हारे पास ये हो गया, ठीक है। सो द मैक्सिमम मैक्स लेफ्ट ये क्या है, मैक्स लेफ्ट वैल्यू वेरिएबल क्या है?
इफ जैसे कि मेरा सामने 0 आ गया तो मैक्स लेफ्ट में देखिए वो चेक कर रहे हो कि मैट डॉट मैक्स मैक्स लेफ्ट कॉमा मिड माइनस लेफ्ट प्लस 1 मतलब इंडेक्स रिटर्न करेगा जो है।
ओके, इंडेक्स रिटर्न करेगा नॉट, चलो ठीक है, इसको बाद में देखेंगे। फिर आता है तुम्हारा ये वाइल लूप। वाइल लूप में अगेन तो तुम्हारा लेफ्ट एल्स इट इट वोंट, वही प्रॉब्लम होती है ना कि जब अगर यू डोंट हैव एनीथिंग इन माइंड, लॉजिक इन योर माइंड, देन यू कांट मूव टू कोड। मतलब क्या करोगे वहां, फिर से फंस जाओगे कहीं ना कहीं, फिर से आके अटकेगा। तो अनलेस एंड अनटिल क्लियर लॉजिक माइंड में नहीं है तब तक कोड में बढ़ना इट्स नॉट अ गुड आइडिया। चलो इसको बाइनरी सर्च से ही ट्राई करते हैं। अगर वी हैव दिस एरे एज अ इनिशियल एरे, सो वी हैव दिस पर्टिकुलर, तो हम लोग ये चेक करेंगे कि लेफ्ट और राइट, ठीक है। तो एक 15 to 8, okay, so 15 2 2 minus 8 8 7 और 11 में भी। so with binary search what we did is, पहले सबसे पहले हमने सबसे पहले इसका निकाला तो नहीं, सम 0 नहीं आया, ठीक है। तो हम लोग फिर क्या करेंगे, मिड एलिमेंट निकालेंगे। मिड एलिमेंट क्या आया तुम्हारा, एक और एलिमेंट डाल देते हैं दोनों, ताकि यही करें, यही एलिमेंट डालते हैं, ठीक है। तो फिर सम निकालते हैं अब
ये
लेफ्ट टू राइट का। तो लेफ्ट टू राइट का यहाँ पे सम 0 नहीं आता है, ठीक है, 0 नहीं आता। अब फिर वही बात है ना कि अगर 0
एक्चुअली
नहीं,
मैंने करके
अच्छा तुमने सॉर्ट करके करा था ना, हाँ, तो उस हिसाब से फिर तुम अपना लॉजिक लगा रहे हो कि सॉर्ट में है तो अच्छा, हाँ
हाँ
हाँ,
हाँ
तब सॉर्ट काम करेगा, बिकॉज
तो 0
क्योंकि
होता
0 बीच में कहीं आने आने वाला है, बिकॉज नेगेटिव वैल्यूज भी रहेंगी और पॉजिटिव वैल्यू भी रहेंगी जो कि कैंसिल कर देंगे सबको। वैसे करके तुमने किया था, ऐसा कुछ था क्या?
हाँ
तब शायद काम करता,
हाँ
तब
हाँ
वो काम कर जाता। बट फिर भी मान लो अगर अगर मान लो सॉर्टेड भी रहते, जैसे कि विदाउट सॉर्टिंग तो ये काम नहीं करने
तो
वाला, बिकॉज
शॉर्टर शॉर्ट
तुम्हें कोई पता नहीं लग रहा ना कि कहाँ पे जाएं। अगर शॉर्ट रहता, अगर मान लो शॉर्ट भी रहता, तो सपोज 8 -7 -4, फिर यहाँ पे तुम्हारा है 4 7 16, ठीक है। तो तुम्हारा एरे, तुम्हारा वैल्यू हो गया ये तो बेसिकली ये क्वेश्चन अगर इंटरव्यू ये पूछ लेता कि अगर वैल्यू अगर तुम्हारा सॉर्टेड है, तब अगर इनिशियली तुम्हारा सॉर्टेड एरे है और तुम्हें सम निकालना है इज इक्वल टू जीरो, तब हाँ तुम बाइनरी सर्च शायद यूज कर सकती थी। लेकिन सर चलो चलते हैं कि कैसे इसमें करें, ट्राई करते हैं। तो पहली बात, मिड मिड क्या आएगा इसमें? 1 2 3 4 4 5 6 6 बाई 3 सो मिड वैल्यू 3 आया। 0 1 2 3 मतलब 3 है ये, 1 2 3 तो ये आया। तब तुम मिड का ये सम करोगे तो क्या आएगा? नेगेटिव नेगेटिव आया।
हम्म
और फिर तुम्हारा ये सम क्या आया इसका? एक अगेन फिर इसमें जाएंगे कैसे, लेफ्ट राइट कैसे जाएं?
मिड से लेकर राइट तक के सब मैं सम कर दूंगा।
ठीक है, सम किया, फिर उसके बाद क्या है? 8 2 16 15 -4 -91 -19 आ गया। देन
हाँ जैसे कि लेफ्ट से लेकर मिड तक मैंने किया, फिर उसका मैंने इंडेक्स निकाला है, देखिए आपने।
मैक्स और मिड माइनस लेफ्ट। अरे तो इंडेक्स क्यों निकाला?
मतलब
तो जो करंट सम जीरो निकल गया तो भेज दो, रिटर्न करो यार। तब
हाँ
इंडेक्स
मतलब
निकालने का क्यों
उसको
मतलब है?
प्रिंट करना है, देख कौन सा इंडेक्स में जीरो आ रहा है, कौन से कहाँ से लेकर कहाँ तक जीरो आ रहा है।
अच्छा, कहाँ से कहाँ तक जीरो आ रहा है? तो अगर मतलब मैक्स लेफ्ट यानी कि हम्म,
मैक्स लेफ्ट में तो जीरो ही है।
अच्छा मैक्स लेफ्ट में जीरो है। ठीक है, फिर क्या हुआ? मैक्स लेफ्ट में जीरो आ गया तो मैक्सिमम क्या हुआ? मिड माइनस लेफ्ट प्लस वन। मिड माइनस लेफ्ट प्लस वन
हाँ
बेसिकली।
तो वही रिटर्न करेगा।
बेसिकली मिड माइनस लेफ्ट यानी कि
वो तो
कौन सा पोजीशन? जीरोथ पोजीशन? नहीं, मिड
हाँ जीरो पोजिशन, मिड माइनस लेफ्ट प्लस मिड मिड जिसमें पॉइंट करे, सपोज मिड फोर फोर इंडेक्स में पॉइंट करे तो 4 - 0 + 1।
तो मतलब -4 पे पॉइंट आउट कर रहा है मिड, तो द वैल्यू इज 3 और इसका मान लो सपोज 1 है।
हाँ तो
मिड माइनस मिड माइनस
हम्म
लेफ्ट प्लस 1 दैट इज
+1।
इक्वल टू 3 अगेन।
हाँ
तो यानी कि मिड ही
3।
किया ना बेसिकली।
हम्म
अच्छा अच्छा।
हाँ यहाँ से लेकर यहाँ तक मैंने कि यहाँ से लेकर यहाँ तक सब मेरा जीरो हो रहा है।
ओके।
एक्चुअली ये वाला कॉन्सेप्ट कहीं पर भी नहीं है, मैंने दिमाग से सोचा है या फिर ड्राई रन किया है।
ठीक है, लाइक आइडिया अच्छा है कि तुम कुछ और सोच रहे हो, बट अगेन फिर इसमें यही हो जाता है ना कि किस बेसिस पे तुम रिटर्न कर रहे हो, किस बेसिस पे तुम सम अगर मान लो नहीं पा रहे हो तो कैसे राइट या लेफ्ट जाओगे, ये इशू है। तो सपोज यहाँ पे वही मुझे समझ नहीं आ रहा, तुम ये मैक्स लेफ्ट क्यों कर रही हो और क्यों ऐसे? मान लो पता भी लग जाता है कि सपोज सम जीरो आ जाता है,
तब
ठीक है, तो फिर उसके बाद ये मैक्स रिटर्न करना मुझे समझ नहीं आया।
हम्म
मैक्स लेफ्ट में तुम ये ऐसे क्यों कर रहे हो?
जैसे कि यहाँ पर मैक्स लेफ्ट में यहाँ पर भी जीरो, यहाँ पर भी जीरो, तो जीरो रिटर्न करेगा मुझे कॉर्नर केसेस के लिए आई थिंक।
अच्छा ओके, चलो इसको इग्नोर मारते हैं थोड़ी देर के लिए, कॉर्नर केस अपना हैंडल हो रहा है, ठीक है। तो लेकिन अगर यहीं पे है तो फिर ये हो गया, फिर नेक्स्ट टाइम गया कि अम,
राइट में जाएगा, अगर नहीं हो रहा है तो जीरो तो राइट में देखेगा, अगर उसमें भी नहीं हो रहा है तो रिटर्न जीरो बाय रिटर्न -1 करेगा।
रिटर्न जीरो। ठीक है, बहुत कॉम्प्लेक्स है, आई डोंट नो, मैं मेरे समझ से थोड़ा ऊपर आ रहा है। आ रहा है, ठीक है।
थोड़ा बहुत तो समझ गए होगे।
हाँ, थोड़ा बहुत समझ गया, बट आई एम स्टिल नॉट अंडरस्टैंडिंग कैसे ये, कब इसको ये एग्जीक्यूट हो रहा है और कैसे वो सोल्यूशन दे रहा है। नहीं, सोल्यूशन तो नहीं आ रहा, बट इन जनरल तुम्हारा थॉट प्रोसेस कैसे इम्प्लीमेंट हो रहा है वो नहीं समझ आ रहा। ठीक है।
ओके
ये
ठीक है।
यही है बस, आई मीन तुमको यही एक्सप्लेन करना होता है जो भी तुमने सोचा है, ताकि सब सामने वाला समझ पाए। ठीक है। तो
हाँ
अब क्या बोलूँ मैं इसमें, मुझे अब तुम समझ नहीं आ रहा क्या है इसमें। ठीक है। तो अगेन, वो सॉर्टिंग के टाइम काम करता, अगर वो इनिशियली सॉर्टेड होता तब शायद कर पाते, अगर तुम्हारा कोई लॉजिक है कि कैसे हम स्विच करें। ठीक है। यू नीड टू फाइंड आउट। दिस थिंग इज कि यार मुझे स्विचिंग करने में कोई वो रीजन नहीं मिल रहा, मिड और तुम किस बेसिस पे कर रहे हो। जैसे तुमने क्या किया है कि लेफ्ट इज,
ये वाला चेक किया कि मतलब मैंने दो एरे लिया, लेफ्ट से लेकर मैं डिवाइड कर ली हूँ एरे को, मतलब एरे को
हाँ ठीक
डिवाइड
है ठीक
किया
है,
लेफ्ट
मिड
से
ले लिया
लेकर
वो तो।
मिड तक।
हाँ हाँ।
हाँ, ये वाला बाउंड्री केसेस है कि ये लेफ्ट से लेकर मिड तक का एक्सिट तो नहीं हो रहा है। अगर एक्सिट हो रहा है तो ये लूप नहीं चलेगा।
इफ लेफ्ट इज लेस देन मिड, मतलब कि मिड से पीछे आ रहा है लेफ्ट, और लेफ्ट क्या चीज है? लेफ्ट तो कभी अपडेट ही नहीं हो रहा है। लेफ्ट तो
अच्छा
कभी अपडेट, कभी बढ़ ही नहीं रहा है, तब तो सेम ही है। चले जा रहे हैं तो लूप यार।
हाँ, और यहाँ पर आई इज इक्वल टू लेफ्ट ले रही हो ना, लेफ्ट से लेकर, तो आई पॉइंटर में लेफ्ट में ही असाइन कर रही हूँ, तो आई पॉइंटर तो मूव हो रहा है।
वो नहीं बोल रहा मैं। देखो, ये इफ स्टेटमेंट है ना, एल
हाँ
स्टेटमेंट तो कभी आया ही नहीं, बिकॉज तुमने कहीं भी प्रोग्राम में लेफ्ट को तो चेंज ही नहीं किया ना। लेफ्ट तुम्हारा क्या है, जीरो ही है।
अच्छा
जीरो
समझ
क्या,
गए।
फिर तुमने मिड को तुमने वो किया, फिर उसके बाद जैसे एफ इफ स्टेटमेंट के अंदर आया, देखा अरे हाँ, लेफ्ट जीरो इज लेस देन मिड, बिकॉज लेफ्ट और राइट की वैल्यू सेम ही थी पहले से, और हम इफ फॉर स्टेटमेंट चले गए, तो बढ़िया हो गया, वो लेफ्ट से मिड तक घुसा, फॉर लूप चला, एग्जीक्यूट हुआ, देन फिर एग्जिट हुआ, वाइल लूप फिर आया, फिर देखा लेफ्ट और वैल्यू की तो कहीं चेंज ही नहीं हुई है, फिर से वापस अंदर इफ स्टेटमेंट आता है, लेफ्ट की वैल्यू अभी भी जीरो है, तो वापस हम टाइम लिमिट एक्सीड बिकॉज इसलिए आ रहा है, बिकॉज लेफ्ट की वैल्यू कहीं अपडेट नहीं हो रही है।
ओके 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 समझ गए अभी।
ठीक है। अब वो कैसे तुम कहाँ पे करोगे, वो तुम अपना दिमाग लो, अपना अपना लॉजिक लगाओ। मैंने तो बता दी कि हाँ, टाइम
हाँ
टाइम लिमिट एग्जिट हो रहा है। ठीक है।
ओके,
एनीवे,
सॉरी फॉर टेकिंग टाइम।
नो इशू नो इशू, आज संडे है तो इट्स ओके, फ्री है, कर सकते हैं। एंड या ये चैनल में मैं अपलोड कर दूंगा ये वीडियो, जो भी है डिस्कशन, और टाइम स्टैम्प रहता है कोई भी क्वेश्चन का, यू
या
कैन स्किप टू इट और तुम उसमें देख सकते हो। जैसे ये, जैसे डाउट वगैरह है, कोई पूछ रहा है, तो मतलब अगर मान लो मुझे इसी सोल्यूशन देखना है, तो आई कैन स्किप टू दैट क्वेश्चन एंड मैं उसी का एक्सप्लेनेशन देख सकता हूँ।
हाँ या
या अपार्ट फ्रॉम दैट और तो कुछ रहा नहीं है। एक मिनट, लेट मी सी। फैंग रोड मैप तो है ही, इट्स नाइस। ओके, जस्ट लेट्स, ओके लेट्स, अब मैं रिकॉर्डिंग बस बंद करता हूँ, ठीक है। वी आर नॉट एंडिंग, 2 मिनट रहना। स्टॉप
ठीक है।
रिकॉर्डिंग।